What's happening, everybody? It's your boy Creative. Go ahead, say it with me. We are back at it again to do what? To create something great. Now, I'm not going to hold you. I'm super excited what I have planned for y'all today. We're going to be going over the difference between stock data and option data before we run a back test on a few of our option algo strats. So before we get started, I need you to go ahead and smash that like and subscribe button. So what you're looking at right now is stock data, right? This is going to be data from the S&P 500. This is the top 500 companies within the New York Stock Exchange, right? So you can see it provides us the open, the high, the low, the close, and the volume, right? So this is actually good if you're back testing equities or stocks, right? But when it comes to option data, as you can see here, it's a little bit more dense, right? And it's a little bit more, it provides a little bit more context as far as what we're going to be trading. Now, some may be asking, where do I get my option data from? Now, I'm not going to hold you. I don't get paid from by them, but game recognizes game. I get it from ThetaData, right? And ThetaData is one of the most comprehensive places that I've seen that provides up-to-date option data and option data that we can use in order to back test our option algo strats, right? And we all remember what a back test is. A back test is being able to take your strategy, drop it off in a time machine, and we want to see how well it performs, right? So going back to our example here, we can see one of the biggest differences that we see, we're going to see new terms, right? One of these first new terms, we're going to see a strike price, and the strike price is just going to be the underlying price that we think that the option contract is going to go to. And the biggest difference between stocks and options is going to be ownership. Whenever you have a stock, you own that particular stock, right? And it could go from 0 to 100, right? And you still own that stock. Now, options, this is going to be the right? This is going to be the obligation to buy or sell, right? So necessarily we don't own it. What we're doing is we're renting exposure for a fixed time period, right? And we're going to have our rights. Our rights is going to be either a call, and call is when we are bullish on the market. We're thinking that the market is going to go up, or we're going to have a put. Put is when we are bearish on the market and we're thinking that the market is going to go down, right? So whenever you go over somebody's house, well, some people don't do this. I would hope that you do, but nonetheless, whenever you go to somebody's house, right, don't you ask before you go to their house, right? So what I want you to do to understand from this is that the ask price is going to be the price that we pay in order to get in to the market, in order to get into the option contract, and the bid price is going to be the price that we pay in order to get out of the option contract, right? Oh, and another big difference here that I want us to understand is that when we buy one option, when we buy one option contract, we're buying 100 shares, the right to buy 100 stocks, right? But when we buy one stock, we're just buying one stock, right? So when I say one option contract, that one option contract equals 100 shares. That gives us the right to buy a call or right to sell a put, right? So we talked about the bid, we talked about the ask. The mid price is going to be the middle price, right? The fair value price. Now, when it comes to being able to set up your algos, I want you to focus on ask and bid, right? Don't necessarily focus on mid. This is how you get messed up. This is how you get wrecked. Delta is going to be one of the Greeks that we are looking at. Delta is going to represent for every $1 move in the underlying stock price, right? How much is the underlying option price going to move? For this particular option contract, we're seeing a delta of 0.9083. So what that is letting me know, for every $1 move, we're seeing a how much? Remember, there's 100 shares and one option contract, right? So in order to get that, we're going to need to do 0.90 times 100, or it's going to be $90. For every $1 move, we're going to see a $90 move in this particular option contract. And theta, what theta represents is going to be how much money are we losing just from holding this option gang, right? So we can see a little bit more differences here, right? And implied volatility is going to be like how much movement is the market doing, for that particular option contract. So as you can see here, the chain depth. Right now, we have for the unique strikes for calls, we have 133 for SPY. for different for different prices that individuals believe that SPY is going to go to, right? So right now we're looking at historic data, right? Because remember, a back test is being able to take your strategy, drop it off in a time machine, and seeing how well it performed, right? So with our historic data from ThetaData, gang, right? This is where we get our data from. Our historic data, we have 133 unique calls on this particular day, and we have 133 unique puts. That's what's up. The lowest one is going to be 300. The highest one is going to be 660, and a few failed without IV. That's all right. Right. So a few things just so we can understand before we get into actually running our back test is the strike price, right? So the strike price is going to be the price at which the contract gives you the right to buy. Remember, if you buy, this is going to be a call because you are bullish on the market, or the right to sell. Now remember, selling is going to be a put because we are bearish on the market. SPY, and SPY is going to be the S&P 500. And the right is going to be either a call or a put, right? We're going to call because we're going to bet that SPY is going to go up, or it's going to be a put because we're going to bet that SPY is going to go down. We already talked about our bid and our ask price and our mid price, right? We already talked about delta and theta. Implied volatility is the market's expectations of SPY's future volatility, right? And this is what's going to be baked into the price. The IV error is just sometimes when it comes to the parquet files that we use for our underlying back test, there's going to be some data errors, right? So that's what we're seeing here. And what's the difference between a parquet file and a CSV? A parquet file just makes it a lot easier for the computer to actually run, right? So right now, if I open this parquet file from 2025 Greeks, now remember I get it from ThetaData, from 2025 Greek, we're not going to be able to see it, but once we actually run it in a back test, it makes it a lot easier for the computer to see it. So here's what it actually looks like, right? Being able to see our option in live, right? So let's say if we were to pick a SPY at 585, a call, that's going to be the C is going to represent a call, and it's going to expire 2024 on the October 15th. If we were to open it at 9:31, as soon as the option, as soon as the market open, just wait 1 minute and open a contract. Again, I wouldn't recommend that the mid, but just for the purposes of illustration, we're just going to use the mid. I would recommend if you're going to buy, you're going to buy at the ask, and if you're going to get out, you're going to get out at the what? The bid, right? For this purpose of this illustration, let's just use it, right? And it's going to be 89 bucks, right? So we have a delta of 0.443. That delta is letting me know that, all right, bet for every $1, right? I know that each option contract is 100 shares. So for every $1, we're seeing that this option contract has an opportunity to make $44, or it's also the inverse, right? I don't want you to think that it's like, all right, bet nothing is guaranteed when it comes to this trading world, gang. So this $44 can either make money, right? Or it can also lose the $44, right? And we know for every minute we're holding this 0 DTE option contract. And these are option contracts that expire the same day, that it's going to cost us. We're going to lose like $1.98, right? If you want to round it up to $2, we're losing $2 every minute just from holding this, gang. So that's the impact of theta, right? So if we were to hold it just for the entirety of the market, right? From open to close, we open at 89 bucks and we can only sell it for $2. So see how much money we're losing just in one session, and this is all theta, right? So theta is eating it up minute after minute, right? And the delta just pretty much evaporated, right? And we see theta is pretty much still there holding strong. Now, I'm not going to hold you on the next video. We're actually going to be going over running our back test, but I wanted us to actually get this brief understanding of what it is, how it works, and the difference between being able to back test stocks and options. So go ahead and drop in the comments, how do you back test your options, right? Do you use parquet files? Is it a vectorized back test, or do you use event-driven back test? Now, I'm not going to hold you. I need y'all to go ahead and smash the like and subscribe button. It is your boy Creative. I'll be back at it again with another episode.